Assalamualaikum and hi, we are from section 1, group 4.
First, we will go through the introduction. So for the introduction, the aim of this project is to design a model of extra high voltage with 132 kilovolt or 275 kilovolt suspension type overhead line insulator based on specific standard requirement. So the type of insulator that we choose is a polymeric insulator, which the kilovolt rating is 275 kilovolt, and it's supposed to be in the same shade. And so next we will go through the objective of this project is to design an overhead line insulator based on specific standard for EHEV, design 2D or 3D using suitable software, and simulate the performance of the insulator design by using console multiphysics. And the problem statement is the amount of insulation needed depends on how large voltage spike caused by internal or external activities and coronal loss, and its loss depend on various factors, for example system frequency, system voltage, and load condition. So next we will go to the technical summary of chosen concept design. So the insulator that we choose is a 275 kilovolt polymeric insulator, and it's supposed to be in the same shade. So for the first design, we use the Autodesk AutoCAD to design this insulator. So from here we get a three picture from the AutoCAD software. So for the first is the insulator length, so we can see the full design of insulator, and then the next picture we can see the distance between two sheds, which we also known as distance between the discs. And for the last picture is the picture for the end of insulator. And then from here also we have give the parameter of insulator that we had been designed. So that's all for the concept design. So next we will go to the flowchart on process on how we complete this work. So for the first is we need to find the information about the polymeric insulator, and then we collecting and finding specification of the insulator, and next we will selecting the type of insulator, which is 275 kilovolts polymeric insulator, which is same shade. And then we make the material selection based on information that been collected. After that, we sketch the 3D design using the AutoCAD. And next is we make a proposal writing and sending proposal. After that, we design one of the selected insulator using FEMM software like console multiphysics. We starting to do the simulation on FEMM analysis software, and then we determine the electric magnetic field distribution, voltage, and more. And after that, we getting the result and data collection, and we make an analysis based on the data that we collect. After that, for the last is report writing, and that's all for the flowchart. So that's all from me.
Okay, Assalamualaikum. My name is Muhammad Zaimur Rabi Mazlan and my metric number is AE190070. And now I'm going to explain about the technical summary of finite element analysis simulation. So the finite element analysis FEA is the process of simulating parts or assembly behavior under the specific circumstance in order to analyze it using the finite element method. So the software that we use is called Multivisit. That is widely used to finite element analysis software package that offer multiphysics simulation capabilities, make it suitable for testing and analyzing the insulator. So an engineer may improve their design and ensure dependability and optimize performance of a wide range of applications, including electrical power system, night electronic, and high voltage equipment by simulating and analyzing the insulator with this software. That is the technical summary methodology for the FEA simulation. So for the first one is the finding. So the information was collected about the polymeric insulator from the internet about its performance to provide the reliable installation and mechanical support for the overhead 275 kV transmission line in the same shed condition. And the next part is design. So the 3D design of the insulator was made using the AutoCAD software. while the design of the finite element analysis (FEA) of the prototype was carried out by using the conformative physics software as the main project application. And next is about the insulator properties. So as we know, silicon rubber is a reliable and durable material for insulator application and is used in high voltage and outdoor application due to its ability to withstand the both electrical and mechanical stress. And lastly, for the documentation part, so the documentation process involves the gathering of information from various sources, including the result and the data from the simulation process. Besides, the discussion also made from the data collected and made the analysis in the final report writing. That's all.
Assalamualaikum warahmatullahi wabarakatuh and hello everyone. My name is Harisaddin bin Harudin. So next I will explain the FEA simulation result. So this is our first result, clean insulator electrical potential. So this figure from bottom of the insulator to the top of insulator is the high voltage to the ground. So there is no significant difference if the author looks at the colors and arrow from the bottom to top of the insulator. The part of color of the core shade is lighter because of low conductivity and less relative permittivity material. The next result is the clean insulator electrical field normal V per M. On the left side is wet condition and no, the right side is a wet condition. The fitting of the top and the bottom insulator is dim and bright and almost same as the color of the other component, but the electrical field normal is higher than the dry condition because the shade of the insulator is affected by water drop and that have a relative permittivity mixed with the relative permittivity of the shade, and then it increase the conductivity of the shade. So for the contaminated insulator electrical potential, there is no significant difference if the author looks at the color and arrow from the bottom to the top of insulator. However, it should be different with contaminated insulation under wet condition than with clean insulator. Probability if the thickness of the volcanic ash is the thicker than this simulation, then it will be more visible and have a more significant difference in the electrical potential. The next is a contaminated insulator, SPF normal V per M. On the right side, in wet condition, the shade actually is darker than dry condition. The reason is that the relative permittivity of contaminant in wet condition is higher than in dry condition because water also has relative permittivity that can affect the volcanic ash. So the last one is the contaminated insulator with a grading ring. Okay, if you see at the model, on the left side is the bottom of insulator. There's one dot is the ring and top of the insulator is the ring also there, so they have two ring in here. So at the right side is electrical potential. The insulator was tested in dry condition with two gradient ring located at the top bottom of the insulator shade. The material of the ring was aluminum alloy A38T with relative permittivity of 1.7 as the figure above. The line of electric field become further when it approach the ring. So when the electric field line is further, so it avoid the dangerous happen such as a spark occurs. So that's all for the result FEA.
Hello, good day everyone. My name is Muhammad Shafi bin Kasmazuli and my matrix number is AE1007. And today I will present to you about the analysis of FEA simulation results and data observations. So for our grouping, we have do the three kind of analysis. The first one is for the clean insulator under wet and dry conditions. Second one is the contaminated insulator under dry and wet conditions. And the third one is the contaminated insulator under dry condition, but with grading and without grading rings. So the first analysis is for the electrical potential for the clean insulator. So here is the analysis for the clean insulator in dry and wet condition. As you can see, the y-axis is referring to the electrical potential, or we call it as voltage, while the x-axis is referring to the arc length, which is the length of the insulator. So 0 is referred to the bottom of the insulator, which is the supply voltage, around 275 kV, and while over than 2500 millimeter is referred to the tops of the insulator, which is referred to the groundings. So as you can see, as the length is approached from 0 to 2700 in, and we can expect that the voltage is decreased linearly with the increase of the length. So there's a situation which is in dry and wet, and there's no difference for that. So no difference to potential graph for the clean insulator and dry and wet conditions. The next one is the for electric field. So as for the electric fields, as you can see, it has the same value for the highest electrical field, which is both have the same. Before it has the at the bottom here, it has the height 1.3 mega V over amps, while for the top it has 1.2. So both of the result show the same, and but the difference is around for the wet insulator, it has non-stable LCV lines like this. This is due to the presence of the droplet of water, which makes the LCV line affected and not uniform compared to the dry conditions. So as you can see, due to the presence of the droplet of water, it have a higher relative conductivity, which affects the electric field performance for the wet conditions of the insulator here. And the second one is for the contaminated insulator, which is in the dry and wet conditions. So same as before, it doesn't have any effects too much compared to both of these conditions. So it's the starting point is around 275 kV for both dry and wet conditions, and it decreases gradually to 0 volts when it approaches to the bottom to the top of the insulator. Now is for the electric fields. So for the contaminated insulator in dry and wet insulator, so there's a difference here. As you can see, the effects is difference is around for the shades. This is located at the shades of the insulator here. When there is a contaminated and water droplets, the electric lines of the insulator is increased compared to the only contaminated in dry insulator. So it increase in terms of electric line. This is located at the shades which have the contaminated layer and also droplet of water. And as you can see also, the electric line on the shade is higher, but when it approach to the middle of the insulator, it becomes lower than at the top and at the bottoms. And the unstable electric lines is affected due to the relative permittivity of the water droplets and also the volcanic ash layer, which is the contaminated materials, and affects the performance of the electric lines around here. And now for the contaminated insulator, for the electrical potential with grading rings and without grading rings in dry conditions. So it's the same. The result is still the same, which there's no difference in electrical potential graph for contaminated insulators in dry condition with and without grading rings. And for the electric field lines, so this is the results. As you can see, due to the presence of the grading rings, the electric field graph under contaminated dry condition is affected a bit as the shade approaches the voltage source and the groundings. So there's a small sudden decrease in the electric field line between 0.1 mega over amps to 0.5 mega over amps, while for under dry conditions without gradings, electric field line decrease linearly as it approaches the middle of the electric field lines. So there's a different around here, as you can see. The difference is when we put the grading rings, there's a sudden decrease of electric field line between the shades of the insulator compared to the insulator without grading rings. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haris Haikal bin Muhammad Saleh. I'm going to present for the risk assessment. So firstly, the method that we use for this experiment is HVAC test. So how we supposedly use very simple. Firstly, we're going to pump the water into the spray and spray the insulator. The insulator is supplied with a 275 kilovolt. So next is hazard. So for the electric shock from high voltage, is how to eliminate or minimize the risk is proper earthing, provide suitable PPE, and safety cage with an interlocking as the power turn up when the door is closed. Next is fire and exposure. To control measure applied to eliminate or minimum risk is install fire detection, fire extinguisher available and visible in laboratory, hang up a poster on how to conduct the flammable. So this is the code of conduct. So we have three conditions: is dry, wet, and continuum. Continuum have two with the dry and wet. So for the dry is a normal test without any rain, but wet we're gonna supply with the rain. So the conclusion is when testing polymer insulator provide safety, accessories, utilize proper PPE, secure the testing area, and adhere to established procedure to minimize potential hazard. So that's all from me. Thank you.